Hello students, welcome to the Department of Mathematics. Myself Mahesh M. As I told you, I'll make a video on the previous year KCET questions from the year 2002 to 2020. So I'm making a series of lecture here. This is the lecture number 1 consisting the previous year KCET questions on the chapter inverse trigonometric functions. Let us see the questions one by one. Question number 1. Question number 1. If cos inverse root p plus cos inverse root of 1 minus p plus cos inverse root of 1 minus q is equal to 3 pi by 4, then the value of q is the question asked in the year 2002 KCET. Students, let us have the expression here: cos inverse root p plus cos inverse root of 1 minus p plus cos inverse root of 1 minus q is equal to 3 pi by 4. Dear students, this LHS is completely in terms of cos inverse. Okay. Now what I am going to do, this second one I am going to convert into sine inverse. Cos inverse to sine inverse. How I am going to convert? We know that some properties of inverse trigonometric functions here. Sine inverse x is equal to cos inverse of root of 1 minus x square. Using this one, I am going to convert cos inverse root of 1 minus x square as sine inverse x, or if you want cos inverse x in terms of sine inverse, you can use the second one, that is cos inverse x equal to sine inverse of root of 1 minus x square. Okay, but here in the square root 1 minus p is there. A small change in that second value, cos inverse of root of 1 minus, I will put this p as in the form of square by writing root p the whole square, so that I can treat it as cos inverse of root of 1 minus x square plus this one as it is, cos inverse root of 1 minus q is equal to 3 pi by 4. Next, cos inverse root p plus, as I told you, cos inverse root of 1 minus x square can be written sine inverse x. Here cos inverse of root of 1 minus root p the whole square can be written sine inverse root p using that standard property, plus cos inverse of root of 1 minus q is equal to 3 pi by 4. Dear students, why I converted cos inverse into sine inverse is, again we know the standard property, that is sine inverse x plus cos inverse x is equal to pi by 2. So here sine inverse x plus cos inverse x I can say, then I will write it as pi by 2 plus again the remaining terms as it is, cos inverse of root of 1 minus q is equal to 3 pi by 4. Then taking pi by 2 to the right hand side, so that cos inverse of root of 1 minus q is equal to, so 3 pi by 4 minus pi by 2. When pi by 2 comes right side, it will be minus pi by 2. So after simplifying, you can observe cos inverse of root of 1 minus q is equal to how much? This 3 pi by 4 minus pi by 2 gives, this is going to be pi by 4. On solving, you will get pi by 4. And root of 1 minus q is equal to cos pi by 4. Taking cos inverse to the right hand side, that will be cos pi by 4. So root of 1 minus q is equal to cos pi by 4 value, you know that 1 by root 2. Now last step, taking squaring on both the side, so that 1 minus q is equal to 1 by 2. If you square on both sides, you will get 1 minus q equal to 1 by 2. And finally qo, taking minus q to the right hand side, 1 by 2 to the left hand side, so that it will be 1 minus 1 by 2, that is 1 by 2. So the answer for this question is, the value of q is 1 by 2. So in the option C is correct. Hope you understood the question number 1. Question number 2. The question asked in the year 2003. Sine of 1 by 2 cos inverse 4 by 5. the value of this expression they are asking. Students, here a small modification we can do, that is sine of 1 by 2 cos inverse 4 by 5 I will treat it as theta. So I will mention that, where theta is equal to cos inverse 4 by 5. So from this I can write cos theta is equal to 4 by 5. So the value of cos theta is 4 by 5. Now we have sin theta by 2. Now to evaluate sin theta by 2, I just want to recall some standard formulas from trigonometry. Students, you know that 1 minus cos theta can be written 2 sin square theta by 2. Okay, this is a famous formula. Now here 2 will be the left hand side. So 1 minus cos theta upon 2 is equal to sin square theta by 2. As we are finding sin theta, this square if I take to the left hand side, it will be square root of 1 minus cos theta upon 2 is equal to sin theta by 2. It means that I got sin theta by 2 value here, that is root of 1 minus cos theta upon 2. The reason to write this formula is we have cos theta value, students. So now straight away I will substitute cos theta value, that is 4 by 5 divided by 2. So on simplifying, taking LCM in the numerator, 5 minus 4, that is going to be 1 divided by 5 into 2 will be 10. So root of 1 by 10 can be written 1 by root 10 is the value of the expression, that is sine of 1 by 2 cos inverse 4 by 5. So in the options, which one is going to be the option? The correct option is B, that is 1 by root 10. Hence this is the solution. Next question. The question asked in the year 2004. If cos inverse P plus cos inverse Q plus cos inverse R is equal to pi, then what is the value of the expression P square plus Q square plus R square plus 2PQR? Dear students, this is our expression to be find out. Here PQR values are required. So consider the given expression, that is cos inverse P plus cos inverse Q plus cos inverse R is equal to pi. What I mean to say, the addition of three functions is equal to pi. Separately, the value of cos inverse P, cos inverse Q, cos inverse R, I will consider these values as pi by 3. Means pi by 3 plus pi by 3 plus pi by 3, I am going to get it as pi. Hence I am taking those values as pi by 3. Now P equal to Q equal to R is equal to, taking cos inverse right hand side, cos pi by 3. So what is the value of cos pi by 3 from the trigonometry? That is 1 by 2. Hence the values of P, Q, R I am getting 1 by 2. So now my job is substituting these PQR values in the required expression. What is the required expression? That is P square plus Q square plus R square plus 2PQR. So your job is to write 1 by 2 in place of P. In Q, again 1 by 2 the whole square, 1 by 2 the whole square plus 2 into P value 1 by 2, Q value 1 by 2, R value is also 1 by 2. On solving, 1 by 2 the whole square is 1 by 4 plus again 1 by 4 plus 1 by 4 plus here 2 and 2 I will cancel out. So 1 by 2 into 1 by 2 remains, that is again 1 by 4. So on addition in the numerator 4, the LCM will be 4, then 4 by 4 is going to be 1. The value of this expression I am getting it as 1. So the option B is going to be the correct answer, because option B consisting 1. Hence this is the solution for the question number 3. Question number 4. If sine inverse x by 5 plus cosec inverse 5 by 4 is equal to pi by 2, then what is the value of x they are asking? The question asked in the year 2004. Let us have the expression sine inverse of x by 5 plus cosec inverse 5 by 4 is equal to pi by 2. Dear students, if you see it properly, somewhere we feel sine inverse x plus if we have cos inverse here, then it is going to be a standard property. What is that? Sin inverse x plus cos inverse x is equal to pi by 2. But the thing is, here cosec inverse 5 by 4 is there. Means we can convert cosec inverse into cos inverse. How to convert? Let us have that solution here. Let cosec inverse 5 by 4, I will treat it as theta for the simplification purpose. Then cosec theta is equal to 5 by 4. To have in terms of cos, I'll just draw a right angle triangle, and cos theta definition is hypotenuse divided by opposite, that is 5 by 4. Then by the Pythagoras theorem, I'll find out the adjacent side. If you use Pythagoras theorem, you will get 3 as the adjacent side. Therefore, I am interested in writing cos theta. So what is cos theta definition? Adjacent divided by hypotenuse, that is 3 by 5. So theta will be cos inverse of 3 by 5. Here also theta and here also theta, means both are equal. It means that, students, sin inverse of x by 5 keep as it is. Now your job is replace cosec inverse 5 by 4 as cos inverse of 3 by 5. So this is equal to pi by 2 as given in the question. So now, using this sin inverse x plus cos inverse x equal to pi by 2, this is also x, this is also x. It means x by 5 is equal to 3 by 5. Both are equal. Then only it is going to be pi by 2. So cancel out 5 and 5 and you are going to get the value of x as 3. So the option for this question is option C is the correct, because 3 is there in the option C. Hence the solution of the problem number 4, KCET question. Let us move the question number 5. The solution of sin inverse x minus sin inverse 2x is equal to, dear students, the solution they are asking means the value of x you have to find out, because it is an inverse trigonometric equation. So you need to find out x value. That x value is itself the solution. Then shall I consider this given expression? Yes, sin inverse x minus sin inverse 2x equal to plus or minus pi by 3. Students, you may think that we can apply sin inverse x minus sin inverse y formula in the left hand side. Yes, you can apply, but it takes a lot of time to get the solution here. So what I mean to say, just you substitute the options in place of x. First you substitute 1 by 3. If you get the RHS pi by 3 or minus pi by 3, then we can think over the option A may be correct, or option B may be correct, or option C may be correct. So it is called as substituting options in the given expression to see LHS equal to RHS or not. This is also one of the method that you can follow. So first option is A, that is 1 by 3 I am taking in place of x in the given expression. So you can see that sin inverse of 1 by 3 minus sin inverse of 2 into 1 by 3. Do you think that you are going to get a standard value, that is pi by 3? No, because sin inverse 1 by 3, sin inverse 2 by 3, we don't have standard value. Of course, you will not get it. Hence, option A is not correct. Option B, x equal to 1 by 4. Then substitute in the given expression sin inverse of 1 by 4 minus sin inverse 2 into 1 by 4. Start getting standard value. Sin inverse 1 by 4, no chance. Here 2 ones are 2 2s are, you can say. Sin inverse of 1 by 2 you may get pi by 6, but here you don't have the standard value. Hence x equal to 1 by 4 is also not correct. Check for option C. X equal to root 3 by 2. Substitute in the given expression wherever x is there. So sin inverse of root 3 by 2 minus sin inverse of 2 into root 3 by 2. Dear students, you may have sin inverse root 3 by 2 as pi by 3 minus, what about this one? 2 and 2 gets cancelled. Sin inverse root 3, do you have standard value? No. Then do you think this is going to be pi by 3? No way. So x equal to root 3 by 2 is also not x value, means option C is also not correct. Do you expect me to take option D and solve like this? No, because option A is also not correct, B is also not correct, C is also not correct, and 100% D is going to be the correct answer. If you want, you can check taking x equal to 1 by 2 in the given expression, that is sin inverse x minus sin inverse 2x, and I am sure that you are going to get either pi by 3 or minus pi by 3. For x equal to 1 by 2, you will get any one. Then you can check minus 1 by 2 also, you will get either plus pi by 3 or minus pi by 3. This is not necessary because it is a CET question. Already you got to know that option D is going to be the correct. This is the solution for the fifth question. Number 6. If cos inverse x equal to alpha and x lies between 0 and 1 and sin inverse of 2x into root of 1 minus x square plus sec inverse 1 upon 2x square minus 1 is 2 pi by 3, and then the value tan inverse 2x is equal to, they are asking, students, they are asking the value of tan inverse 2x. Very simple question asked in the year 2006. So here cos inverse x equal to alpha, don't think much about this, just neglect it, only consider this expression. So sin inverse of 2x into root of 1 minus x square plus sec inverse of 1 upon 2x square minus 1 is equal to 2 pi by 3 is the given expression. I tell you students, remembering the properties of inverse trigonometric function is very important. Here see, the first one I will not simplify anything because I just want to go to the next one. Dear students, sec inverse of 1 upon 2x square minus 1, can we write in terms of cos inverse as 2x square minus 1 by the reciprocal property? Yes. So this is equal to 2 pi by 3. Now sin inverse 2x into root of 1 minus x square, there are two values, there are two functions for this, that is you can write 2 sin inverse x or 2 cos inverse x. Both will be equal to sin inverse of 2x into root of 1 minus x square. This is one. The second one, cos inverse 2x square minus 1 will be equal to 2 cos inverse x. You can ask me, sir, how we get all these? These are nothing but the properties of inverse trigonometry. If you substitute x equal to cos theta in the LHS, then you are going to get 2 cos inverse x. That is the theory part. Now I am going to substitute directly. Cos inverse of 2x square minus 1 is 2 cos inverse x. Now it is left to you. Will you write sin inverse in terms of sin inverse here? Means 2 sin inverse x? No, you will not write because already we have 2 cos inverse x, one function. So better you go for the 2 cos inverse x. 2 cos inverse x is equal to 2 pi by 3. So very simple simplification, 4 cos inverse x is equal to 2 pi by 3. On simplifying, 2 1s are 2 2s are. So that 2 cos inverse x is equal to just pi by 3. Still taking 2 to the right hand side. So cos inverse x is equal to pi by 6 I get, and only x equal to cos pi by 6. Dear students, cos pi by 6 value is from the trigonometric table we are going to have, this is root 3 by 2. This is not the answer, this is just the x value. Still we need to have tan inverse 2x. So here I'll consider tan inverse 2x. So what is the value of x you got here? Root 3 by 2. So substitute here root 3 by 2. 2 and 2 will get cancelled. So tan inverse root 3. Dear students, again from trigonometric table, tan inverse root 3 is pi by 3 from the table. Hence the answer for tan inverse 2x is pi by 3. Option C is the correct answer. Hope you followed. Let us move into the next question. Number 7. If A is greater than B is greater than 0, then the value of tan inverse A by B plus tan inverse of A plus B upon A minus B depends on this expression. The value of this expression depends on what? Option A, both A and B. Option B, B not A. Option C, A and not B. Option D, neither A nor B. So the value we should find out. Later we can compare the options here, which option is going to match the answer. So let me take the given expression. Tan inverse of A by B plus tan inverse of A plus B upon a minus b. So in the first there is no simplification, just keep tan inverse of a by b only, plus in the second I am going to simplify. Already we have seen this type of questions in theory part. A common, so that 1 plus b by a we get, upon even in the denominator also a common, so that 1 minus b by a we get after taking a common. Definitely a and a are going to cancel. Then the remaining steps, tan inverse of a by b plus remaining terms I'll write tan inverse of 1 plus b by a upon 1 minus b by a. This is the remaining step, remaining terms from the above step. Dear students, I just want to recall a standard formula, tan inverse x plus tan inverse y is equal to tan inverse of x plus y upon 1 minus x into y. Do you think this expression is going to match the RHS of the formula? Tan inverse is there, tan inverse is there, x plus y, yes, in the numerator, divided by 1 minus x into y. So here one small x we need, no? That x value I am taking it as 1, because here we said x is 1. So the same x I am writing, nothing will happen to this b by a. Therefore, tan inverse a by b remains as it is again, one more time. Plus, if I apply this RHS to this expression, tan inverse of x plus y upon 1 minus x into y will be tan inverse x plus tan inverse y. Be careful, y value is b by a. Hope you followed this one. So after that, tan inverse a by b, okay, plus tan inverse 1 value from the table, pi by 4, plus tan inverse b by a in terms of cot inverse reciprocal, that is a by b. The reason to write in terms of cot inverse, tan inverse x plus cot inverse x property, that is pi by 2 plus pi by 4. So the answer for this 90 degree plus 45, 135 degree, that is 3 pi by 4. Now the expression has the value 3 pi by 4. Now is this 3 pi by 4 depends on both a and b? No. B not a? No. A not b? No. This 3 pi by 4 definitely does not depend on a and b. It will not depend on a, b. So neither a nor b is the correct answer. So the 3 pi by 4 depends neither a nor b. Hence the solution. Next question, number 8, asked in the year 2007 KCET. The solution, again the solution of tan inverse x plus 2 cot inverse x equal to 2 pi by 3. What I said, the solution means it is an inverse trigonometric equation. They are asking solution means you need to find out x value, remember that. So the given expression, tan inverse x plus 2 cot inverse x is equal to 2 pi by 3. Dear students, just by looking at the LHS, you can think over that. Why can't we write 2 cot inverse x as cot inverse x plus cot inverse? Did you understand why I am writing cot inverse x plus cot inverse x? Because I am going to use a property of inverse trigonometry, that is tan inverse x plus cot inverse x as pi by 2 and plus cot inverse x. So that's why I have written 2 times as cot inverse x plus cot inverse x. Now shifting pi by 2 to the right hand side, very simple simplification. So that cot inverse x equal to 2 pi by 3 minus pi by 2. So here cot inverse x is equal to 120 degree. 2 pi by 3 means 120 degree minus 90 degree. 120 minus 90 is 30 degree, that is going to be pi by 6. So cot inverse x is pi by 6, then x is equal to, is it cot pi by 6? Definitely. So from the table, cot pi by 6 is root 3. Remember the standard table, that is root 3. Therefore x value is root 3. Where is in the option D? Yes, D answer is going to be the correct option for this question. That is the solution of the given expression. Hope you followed the logic and the magic for this question. Number 9. The value of the expression they are asking. The expression I will write here. Sine of 2 cos inverse root 5 divided by 3. Students, these are straight questions. You have to simplify the expression. You will get a number. Then you have to check the options. The which option is going to match to that answer, that is going to be the correct option. So here, don't think much about the options. Directly you need to simplify the given expression. So here, sine, as usual, the previous one question I solved of this type, I will treat it as theta. So theta will be cos inverse root 5 divided by 3. Then you can write cos theta as just root 5 by 3. Now think over sine 2 theta. Sine 2 theta, do you think any famous formula for sine 2 theta? Yes, what is that? 2 sine theta into cos theta, a very famous formula in the market. That is sine 2 theta as 2 sine theta into cos theta. Now the question is, if you have cos theta value, because here is waiting, cos theta is root 5 by 3. What about sine theta? Is it possible to get sine theta from cos theta? Yes. How? By right angle triangle. So cos theta definition, adjacent divided by hypotenuse. Then opposite side, by the Pythagoras theorem, 3 square minus root 5 the square. So that 9 minus 5, 4, square root of 4, that is 2. So the opposite side is 2. And I want sine theta, then I'll apply the sine theta definition. What is that? Opposite divided by hypotenuse. So this is going to be sine theta. Sine theta is there, cos theta is there. Just substitute in this famous formula, 2 into sine theta, 2 by 3, cos theta, root 5 by 3, then simplify it. 2 into 2, 4, root 5 divided by 3 into 3, 9. So what is the value of the expression? 4 root 5 divided by 9. Now check the options. Is the option C? Yes, this is going to be the correct answer. The question asked in the year 2007, the value of the expression. Hope you followed. Let us move into the next question. Number 10. Similar to the previous question asked in the year 2008 CET. So let us take the given expression, sine of 2 sine inverse root of 63 upon 65. I'll follow the same method as I solved in the previous question, treating this as theta, where theta is equal to, what is that? Sine inverse of root of 63 by 65. This I am treating it as theta. Hope you followed. Now from here, sine theta value is root 63. I will just modify root 63 upon root 65. You can write like that, because square root of a by b can be written square root of a upon square root of b. Now the question, again sine 2 theta. Students, do you think the same famous formula sine 2 theta? Yes, of course. That is 2 sine theta into cos theta. Then do you have cos theta? Because already sine theta is there. Just you need to find out cos theta. How? By the same method, that is right angle triangle, Pythagoras theorem. Here sine theta is given, means opposite side divided by adjacent side. Then what about so sine theta is given, means opposite divided by hypotenuse, that is root 63 upon root 65. Now we need to find out adjacent side. How? By Pythagoras theorem. Pythagoras theorem says root 65 square minus root 63 the whole square. 65 minus 63 is a 2, that is square root of 2 will be the adjacent side. Then cos theta, adjacent side divided by hypotenuse. I am saying adjacent and hypotenuse, but I am writing their values. Hope you are getting it. So this is cos theta. Then come back to this expression, 2 into sine theta value root 63 upon root 65. Then cos theta value root 2 divided by root 65. Carefully you have to simplify. 2 in the numerator, root 63 into root 2 using square root of A into square root of B is equal to square root of AB. 63 into 2, is it 126? Yes. Divided by root 65 into root 65. Root 65 into root 65 will be root 65 the whole square. So root and square will cancel, only 65 remains. So in the denominator only 65 is the value of the given expression. So where in the options, is the option A correct answer? Yes, the answer for the 10th question is option A. This is the lecture number 1 consisting 10 questions. Then remaining questions I'll take in the next lecture. Thank you, students.